Welcome to Animal Uncovered, the podcast where we explore the most unbelievable life cycles in the natural world. From the moment life begins to the moment it ends, nothing is as simple as it seems. Somewhere deep in the papyrus swamps of Central Africa, where the water is the colour of old tea and the air sits heavy with heat and decay, something is standing very, very still. It has been standing still for over an hour, perhaps longer. The water around its legs barely moves. The reeds press close on every side. A marsh mongoose slips through the undergrowth nearby and does not notice it. A jacana skitters across a lily pad within arm's reach and pays it no mind. Even the frogs resume their business, because whatever is standing there has become, at least to them, part of the landscape itself. But it is not part of the landscape, it is watching. With eyes that face forward, eyes designed for depth perception, for precision, for judgment, it watches a small, quiet disturbance just beneath the surface of the water. A lungfish, long and prehistoric and oblivious, is moving through the shallows. It does not know what is above it. It could not know. Nothing in its biology has prepared it for this particular threat. And then, in a movement so sudden it seems to violate some unspoken contract between stillness and motion, the creature lunges. Not a graceful dive, not the elegant sweep of a heron. This is something far more primal. The whole body tips forward like a falling tower, wings spread wide for balance, beak crashing into the water with the force and geometry of a trap springing shut. In the chaos of mud and spray, the lungfish thrashes once, twice, and then it is over. The long neck straightens, the beak tilts skyward, and what might be the most bizarre-looking bird on the African continent stands upright once more, a writhing meal clamped in jaws that evolution spent millions of years perfecting. It turns its head slowly, surveying the swamp with an expression that can only be described, in thoroughly unscientific terms, as contempt. Its beak is enormous, a grey, hook-tipped, almost comically oversized instrument that looks less like a beak and more like a Dutch wooden clog attached to the face of something ancient and important. Its eyes are pale yellow and unblinking. Its plumage is the grey-blue of a storm rolling in over an open plain. It stands nearly 5 feet tall, and it does not appear to be impressed by anything. This is the Shoebill stork, and if you have never encountered it before, you're about to understand why biologists, wildlife photographers, local communities, and a growing audience of internet strangers have all, independently and with great enthusiasm, arrived at the same conclusion: that this bird is extraordinary in ways that take some time to fully appreciate. Today we go deep into the swamps. Part 1. Why this animal matters. There are roughly 10,000 species of bird on this planet. Most of them are charming, or musical, or colourful, or fast. A small number of them are large and impressive. An even smaller number possess a combination of physical peculiarity, behavioural intensity, and evolutionary isolation that makes them feel genuinely singular, like they arrived from a slightly different version of Earth. The shoebill Baleniceps rex belongs to that last category. Its scientific name translates loosely to whale-headed king. This is not hyperbole. The bill alone can measure 32 centimetres in length and 10 centimetres across at its widest point, proportions that, on a bird, seem almost satirical. It is the third largest beak of any bird alive today, after the pelican and the toucan. But where the pelican's beak is a scoop and the toucan's is a gaudy ornament, the shoebill's beak is something else entirely. A weapon, a precision instrument. the culmination of a very long and very specific evolutionary project. The shoebill is found in a narrow band of tropical East and Central Africa, primarily the swamps of Uganda, South Sudan, the Democratic Republic of Congo, Zambia, and Rwanda. It favours the densest, most impenetrable papyrus marshes it can find, the kind of habitat that discourages almost everything, including most humans. This geographical preference has helped keep the shoebill mysterious for longer than most large animals manage to remain so. It was formally described by Western science only in 1851, which is remarkably recent for a bird this size. Arab traders had known about it far earlier. They called it Abu Markub, meaning father of the shoe, a name that captures the beak's distinctive silhouette with admirable economy. Local communities in Sudan and Uganda had lived alongside it for generations, weaving it into folklore and in some cases regarding it with something approaching reverence. When European naturalists finally encountered it, reactions were mixed between fascination and mild alarm. One early observer described the bird as looking like a creature assembled from spare parts by someone who had never seen a bird before. Others noted its habit of standing motionless for extraordinary lengths of time, its unnerving tendency to stare directly at humans without any of the nervousness you'd expect from a wild animal, and its method of greeting. A rapid clattering of the upper and lower mandibles like rapid applause, or the noise a football rattle makes, which sounds in the middle of a silent swamp like something breaking. The shoebill has become, in recent years, something of an internet phenomenon. Videos of it staring down wildlife photographers, bowing deliberately to humans it apparently tolerates, and dispatching prey with what looks like unnerving surgical precision have accumulated hundreds of millions of views. It is, depending on your perspective, either the most majestic or the most unsettling bird alive. But beneath the viral charm lies a genuinely compelling biological story. How did this bird come to look and behave the way it does? What does its life actually consist of, from the moment it cracks through its shell to the lonely years it spends patrolling its private stretch of swamp? And what does the future hold for a species that, despite its ferocious appearance, is surprisingly fragile in the face of the pressures human civilization places on the natural world? Those are the questions this episode is built around. The answers, as it turns out, are as strange and as rich as the animal itself. Part 2: Evolution and Origins. To understand the shoebill, you have to be willing to step back not just decades or centuries, but tens of millions of years. Because this is a bird with deep roots, a lineage that reaches into geological time and connects it in ways that took scientists a surprisingly long time to unravel, to some of the most ancient and recognizable birds on the planet. For much of the 20th century, taxonomists placed the shoebill within the order Siconiiformes, the storks and herons. The logic was reasonable. It's large, it lives near water, it eats fish. But looks can deceive, and the more closely scientists examined the shoebill's anatomy, behavior, and eventually its genetics, the more complicated the picture became. The most significant revision came with the rise of molecular phylogenetics, the technique of comparing DNA sequences to build evolutionary family trees. When researchers applied this to the shoebill, the results were surprising. The shoebill does not belong with the storks at all. Its closest living relatives are the pelicans, and after them the herons. It occupies its own family, Balaenocipitidae, and within the larger grouping Pelecaniformes, an order that also includes gannets, cormorants, and frigate birds. This reclassification is more than an academic footnote. It reframes the shoebill as the product of a lineage that diverged from the common ancestor of pelicans and herons somewhere around 30 to 40 million years ago during the Eocene epoch, a period when the world's climate was warmer and wetter, when vast inland seas and enormous river systems crossed Africa, and when the evolutionary opportunities available to large water-dependent birds were rich and varied. The fossil record for the shoebill's direct ancestors is sparse, which is typical for birds whose bones are hollow and fragile and decompose quickly in the wet environments they favour. But there is enough evidence to suggest that Balaenicipitidae has been a distinct and isolated lineage for a very long time. A fossil relative, Goliathia andrewsi, was recovered from Eocene deposits in Egypt and dates to approximately 35 million years ago. Another fossil, Palidavis ritchii, suggests that large shoebill-like birds were hunting shallow African waterways long before our own genus existed. What this lineage preserved through all those millions of years was essentially a single very successful strategy: get very large, develop an extraordinary beak, inhabit the densest swamps available, and hunt the slow, ancient, air-breathing fish that live in oxygen-poor water where other predators cannot easily follow. The fish in question, the lungfish especially, but also catfish, tilapia, and the Nile monitor lizard, are themselves ancient creatures. The African lungfish, Protopterus, has existed in roughly its current form for over 300 million years. It breathes air. It can survive drought by burrowing into mud and entering a state of metabolic dormancy for months. It is, in a sense, a relic of the Devonian era, a time when fish were first experimenting with the idea of leaving the water. The shoebill evolved in part to eat this survivor. There is something almost mythological about that relationship. One ancient creature hunting another across the long corridors of geological time. The beak then is not an accident or an eccentricity. It is the solution to a very specific engineering problem. How do you capture a large, strong, slippery animal in shallow, murky water, reliably and efficiently, in an environment that rewards stillness over speed? The hooked tip provides the grip. The sharp lateral edges allow the bird to cut through vegetation. The overall size creates a bucket-like catching surface, wide enough to compensate for the imprecision that muddy water creates. The whole structure is, in the language of evolutionary biology, exquisitely adapted. The shoebill also retained something from its ancient lineage that most modern birds have largely lost: a quality of stillness, of patience, of profound metabolic calm that makes it one of the least frenetic large birds alive. It does not bustle, it doesn't rush. It inhabits its swamps with the unhurried authority of something that has been doing this for a very long time, because in a very real sense, it has. Part 3. The Life Cycle. Phase 1. Birth and the First Hours. The shoebill story begins in one of the most carefully chosen locations in the African wetland, a nest platform built on floating vegetation, or occasionally on a small island or a termite mound raised above the waterline, in the deepest, most inaccessible part of the swamp it can find. The nest itself is an impressive construction. A breeding pair will spend weeks building it, a wide, flat platform of aquatic vegetation, reeds and grass that can measure up to 2.5 meters across. The effort invested signals the seriousness of what is about to happen. This is not a temporary structure. A pair may return to the same nest site year after year, refurbishing and expanding it each breeding season. Shoebills are monogamous. They pair for extended periods, possibly for life, though the full extent of their pair bonds is still being studied. Courtship is low-key by bird standards. No elaborate aerial displays, No colourful plumage changes. The primary signals are behavioural. The male and female engage in mutual bill clattering, that extraordinary percussive greeting that carries across the swamp and announces to anyone listening that this territory is occupied and that the bond between its residents is intact. They bow to each other, they preen each other's feathers, they stand together for long, silent periods that seem to function as a kind of companionship. The female typically lays between 1 and 3 eggs, though 2 is most common. The eggs are large, roughly the size of a goose egg, white and slightly chalky in texture. Both parents share incubation duties, taking turns sitting on the nest while the other feeds. The incubation period lasts about 30 days, during which the parents face one of their most demanding ongoing tasks, keeping the eggs cool in the tropical heat. This is a challenge that is rarely discussed but is actually critical to shoebill reproduction. The swamps of Central Africa can reach temperatures that would be lethal to developing embryos if the eggs were left unattended. The parents compensate by collecting water in their enormous beaks and pouring it over the eggs, a behaviour called egg watering, which they may do up to 10 times per day during peak afternoon heat. They also shade the eggs with their wings, standing over the nest with plumage spread like an umbrella. This level of parental investment, before the chicks have even hatched, speaks to the demands that raising a shoebill places on its parents. When the eggs finally crack, the chick that emerges is simultaneously vulnerable and oddly formidable looking. It is covered in silver-grey down, has disproportionately large feet, and immediately fixes you, or its parent, with a stare of unsettling directness. The beak is already beginning to show its distinctive shape, though it will not reach full size for several months. And Phase 2, sibling rivalry in the first weeks. The family dynamics of the shoebill are among the most studied and most discussed aspects of its life history, partly because they reveal a hardness that sits in interesting tension with the devoted parental behaviour that surrounds it. When a nest contains 2 or 3 chicks, the parents do not treat them equally. Resources in the swamp are finite. Raising a shoebill to maturity is expensive. It requires more fish, more water ferrying, more time spent hunting than most birds demand. And so, from the earliest days, the eldest and largest chick asserts dominance. It begs more loudly, it positions itself most advantageously, and if necessary it physically harasses its younger siblings. This behaviour, siblicide or at minimum competitive exclusion, is well documented in shoebill nests. Younger chicks are pecked, displaced from food deliveries, pushed to the margins of the nest. In years when fish are scarce, the youngest chick typically does not survive beyond the first few weeks. Even in good years, it is unusual for more than one chick to fledge from a nest. The parents do not intervene in these conflicts. They do not mediate. They continue to deliver food to whichever chick presents itself most insistently, which, by definition, is the dominant one. This apparent cruelty has an evolutionary logic. A shoebill that attempts to raise 2 chicks to full size in a marginal year risks losing both. By allowing competition to determine which chick receives full investment, the parents maximize their chances of producing at least one healthy, well-fed offspring. It is a brutal form of quality control, and it is one that appears throughout the bird world, particularly in species where the young are large, slow-growing and nutritionally demanding. The surviving chick grows quickly through its first weeks, fed on regurgitated fish and water. The parents are attentive but not coddling. By 4 weeks, the chick is large enough to thermoregulate partially, reducing the need for constant shading. By 6 weeks, it is beginning to explore the edges of the nest platform, testing its legs, looking out at the swamp with an expression that seems to combine curiosity and wariness in equal measure. Phase 3, the juvenile phase. The juvenile shoebill is in many ways a miniature version of the adult. The same basic proportions, the same forward-facing eyes, the same slightly menacing stillness, but rendered in softer colours. Where the adult's plumage is the muted grey-blue of deep shadow, the juvenile is browner, more muted, more easily overlooked. This is almost certainly adaptive. A young bird that cannot yet defend itself or hunt effectively benefits from a degree of visual camouflage that the adult, in its maturity and authority, no longer needs. By around 3 months of age, the chick is beginning to exercise its wings. It beats them against the air with increasing vigour, building the flight muscles it will need for the longer journeys of adult life. It is not, however, making any attempt to fly. The shoebill's developmental timeline is long by bird standards. They are what biologists call a semi-altricial species, meaning the young are helpless at hatching, but develop into competent individuals over an extended period. First flight typically occurs at around 95 days, just over 3 months. But flying is merely the beginning of competence. A fledgling shoebill that has just mastered basic flight still lacks the hunting skills that will define its adult life. Those skills, the ability to read water, to identify the subtle surface disturbances that indicate fish moving below, to stand motionless for the precise duration required, to time the explosive lunge with sufficient accuracy, are learned, not instinctive. They develop through practice, through failure, through the gradual accumulation of experience that takes months and arguably years to fully mature. During this post-fledgling period, the young shoebill remains loosely associated with its parents' territory. It shadows them, watches them hunt, practices on its own in the shallower and less productive areas of the swamp. Catch rates among juveniles are poor. Estimates suggest young birds succeed on a fraction of the attempts that experienced adults manage. The slow development of hunting skill is one of the reasons shoebill populations are sensitive to disruption. Every bird lost in adolescence represents not just the loss of a breeding adult, but the loss of years of accumulated hunting knowledge. At around 6 months, the juvenile is feeding itself regularly, though probably not yet at the caloric intake levels it will need as a full-sized adult. By its first year, it looks much like an adult, though a trained eye can distinguish it by the slightly duller coloration and the proportionally smaller beak, which continues to grow and develop through the 2nd and 3rd years of life. Phase 4, Adolescence and the Long Road to Maturity. The shoebill is not sexually mature until it is approximately 3 to 4 years old. This is an unusually long developmental trajectory for a bird, and it has significant implications for the species' population dynamics. In the years between fledging and first reproduction, young shoebills disperse from their natal territories and begin to establish their own ranges within the larger swamp ecosystem. This dispersal phase is one of the least studied periods of their lives, partly because they're moving through difficult, inaccessible terrain, and partly because they lack the territorial behaviours that make adults easier to find and track. What we do know is that during this period, young shoebills are establishing the solitary habits that will define their adult lives. The shoebill is one of the most solitary of all large birds. Adults maintain exclusive feeding territories, sometimes covering several square kilometres of swamp, and they enforce these territories actively. Encounters between adult shoebills outside the breeding season are typically agonistic. There is bill clattering, there are threat displays, and if the intruder does not retreat, there may be direct physical confrontation. This solitary lifestyle reflects the economics of the swamp. lungfish and large catfish are not uniformly distributed. A productive hunting site, a shallow, slow-moving channel with good fish density and clear sight lines, is a resource worth defending. An adult shoebill that tolerates competitors in its territory is an adult that may not catch enough fish to maintain itself. Solitude in the papyrus swamp is not a character trait. It is a survival strategy. Phase 5. Reproduction. Against the backdrop of this solitary existence, the breeding season represents a remarkable and temporary exception. For a few months each year, typically during the dry season, when water levels drop and fish become concentrated in smaller areas, making hunting more productive, adult shoebills reconnect with mates or seek new ones, and engage in the business of reproduction. The timing of shoebill breeding varies by region, but the dry season logic is consistent. Lower water levels mean denser fish populations in the remaining pools and channels. Denser fish populations mean more reliable food delivery to the nest. It is a simple equation, but it governs almost everything about when and how shoebills breed. Pair formation or reinforcement involves those characteristic bill-clattering displays, mutual bowing, and a period of close proximity that seems to function as a calibration of compatibility. Once committed, the pair works together with impressive coordination. While one bird incubates or broods, the other hunts. While one returns to the nest to relieve its partner, the other heads immediately to its preferred fishing channel. The division of labour is precise and apparently intuitive. The nest construction and incubation behaviour described earlier play out over the weeks that follow. If all goes well, if the rains do not flood the nest, if a Nile monitor lizard does not discover the eggs, if the breeding pair does not encounter serious disturbance, a chick will hatch, and if the hunting is good and the season cooperative, that chick will fledge. And if it survives its long, exposed adolescence, it will eventually join the small population of adults patrolling Africa's great papyrus swamps. Phase 6. Aging and Death. In captivity, shoebills have lived to at least 36 years, and possibly longer. In the wild, the lifespan is almost certainly shorter, given the hazards of life in an environment that includes Nile crocodiles, pythons, eagles, and the constant challenge of finding food. Estimates for wild shoebill longevity range from around 15 to 25 years, though this is difficult to verify precisely given how hard the birds are to track. Shoebills do not appear to senesce dramatically. That is, they do not seem to show obvious physical deterioration in their later years in the way that some mammals do. The beak continues to serve its function. The hunting instinct remains sharp. What age likely takes is the subtle edge, the reflexes, the speed of the lunge, the ability to maintain the metabolic demands of territorial defense and breeding simultaneously. An old shoebill, like an old predator of any kind, gradually loses ground. Its territory shrinks as younger, more vigorous individuals press its margins. Its catch rate drops. It may skip breeding seasons when its body cannot support the dual demands of hunting and reproduction. Eventually, unable to catch enough food to sustain itself, it declines. It is rarely preyed upon in its final state. There are not many things in the African swamp equipped to tackle a bird that stands nearly 5 feet tall and can swing that beak with significant force. It simply fades. In the solitude of the swamp it has defended for decades, and is gone. Part 4. Biology and Adaptations. The shoebill is, from a purely anatomical standpoint, a masterpiece of functional design. Every major feature of its body reflects a specific ecological pressure, a specific problem solved by natural selection over a very long time. Begin with the beak because nothing else about the shoebill makes full sense until you understand what that beak can do. It is not simply large, it is precisely shaped. The upper mandible terminates in a sharp, strongly recurved hook. This is the anchor point that prevents large prey from escaping once caught. The edges of both mandibles are sharp enough to cut through aquatic vegetation and to slice through the gill plate of a large fish. The overall width of the beak creates a broad catching surface that compensates for the unpredictability of striking in murky water. Inside the beak, the surface texture helps maintain grip on slippery, struggling animals. But the beak serves another function that is less immediately obvious. It is one of the primary tools of thermoregulation. The shoebill uses its beak to collect and transport water from the swamp to its eggs, as already described. But it also uses it to wet its own plumage on very hot days, creating an evaporative cooling effect. The beak's large surface area may itself radiate excess heat. In an environment where midday temperatures can exceed 40 degrees Celsius, these cooling mechanisms are not luxuries, they are survival equipment. The eyes deserve equal attention. They face forward, a configuration that in birds is strongly associated with predators that need precise depth perception. Barn owls have forward-facing eyes. Hawks have forward-facing eyes. Most hunting birds that rely on accuracy rather than all-round vigilance share this trait. The shoebill's pale yellow eyes are large relative to its skull, which improves light-gathering capacity and aids hunting in the low-light conditions of dense papyrus thickets. Combined with binocular vision, this gives the shoebill the ability to calculate with remarkable precision the distance to a target beneath the water surface, even compensating for the refractive distortion that water creates. The neck and body provide the mechanism for the lunge. Unlike herons, which have a long, flexible neck adapted for a smoothly extended strike, the shoebill's neck is shorter and more muscular. When it strikes, the whole body pitches forward, and the kinetic energy of that falling weight is added to the muscular force of the neck extension. The result is an impact powerful enough to stun or kill large prey on contact. A lungfish can weigh several kilograms and possesses significant muscular strength, and the shoebill needs to subdue it quickly to prevent injury and escape. The feet are long-toed and unwebbed, which might seem counterintuitive for a bird that spends most of its time in water. But the shoebill does not swim. It wades. Its long toes distribute its weight across soft, unstable substrate, lily pads, floating vegetation, soft mud, allowing it to move through swamp terrain that would sink or destabilize a less well-equipped animal. This is the same adaptation seen in the lily trotter birds, and it works on precisely the same principle as snowshoes. Surface area spread over a wide base reduces pressure on any given point. The plumage of the adult shoebill is a grey-blue that functions as camouflage in the dim light of the swamp interior. Standing motionless among the grey-green papyrus stems, it becomes almost invisible, a trick that serves both its hunting and its relatively low-threat lifestyle as an apex bird predator with few natural enemies. The plumage also has a slightly oily texture that provides some waterproofing, essential for a bird that regularly plunges its entire front half into water. One of the most discussed aspects of the shoebill's behavioral biology is its patience, its extraordinary capacity for motionless waiting that can extend for hours at a time. This is not simply a hunting tactic. It is a reflection of the shoebill's unusually low metabolic rate for a bird of its size. Birds in general have high metabolisms. Their warm-blooded, flight-capable bodies demand constant fuel. The shoebill has evolved a system that runs at something closer to idle when conditions permit. It does not pace, it does not fidget. It conserves energy with a discipline that is genuinely remarkable, and that allows it to sustain itself in an environment where hunting success, while reliable, is not constant. Part 5. Ecosystem Role. The shoebill does not exist in isolation. Its presence in the papyrus swamps of Central Africa has effects that ripple outward through the ecosystem it inhabits, shaping and being shaped by an intricate web of relationships. As an apex predator in its specific habitat, the shoebill exerts top-down pressure on populations of large fish, particularly lungfish, catfish, and tilapia. Predator-prey relationships of this kind play an important regulatory function. By preferentially taking the largest, most accessible individuals, the shoebill removes animals that would otherwise consume significant quantities of smaller fish and aquatic invertebrates. The presence of a healthy shoebill population is, in a sense, a marker of a healthy swamp ecosystem, and conversely, the disappearance of shoebills from an area is often a signal that the broader ecosystem is under pressure. The lungfish is worth particular attention in this context. As described earlier, the African lungfish is ancient, tenacious, and ecologically significant. It occupies a position in the food web that links aquatic and semi-terrestrial systems. It eats fish, amphibians, plant material, and invertebrates, and in turn is eaten by crocodiles, large wading birds, and monitor lizards. The shoebill is one of the few predators specifically adapted to target large lungfish efficiently, and its hunting may help prevent individual lungfish from growing so large and so numerous in certain channels that they outcompete other species. The shoebill also has relationships with other species that are less directly predatory. Nile crocodiles share its wetland habitat, and while adult shoebills are rarely, if ever, taken by crocodiles, their nests and eggs are vulnerable to crocodile predation. African fish eagles compete for some of the same fish species, though they tend to take smaller prey and hunt by diving from height rather than by the shoebill's ambush method, reducing direct competition. Hippopotami in some parts of the shoebill's range create open water channels through dense papyrus by their movement and grazing, channels that the shoebill exploits as hunting corridors. There is also an interesting relationship between shoebills and the human communities that share their swamp environments. In parts of Uganda and South Sudan, local fishermen have observed that shoebills seem to follow their boats and activity, taking advantage of the fish disturbed by net setting and paddling. Whether this constitutes a genuine commensal relationship, one species benefiting from another without affecting it, or simply opportunistic behavior is debatable, but it points to a degree of behavioral flexibility and associative learning that adds nuance to the shoebill's reputation as a solitary, self-contained predator. The papyrus swamp itself is an ecosystem of extraordinary ecological value. Papyrus beds are among the most productive aquatic habitats in the world, fixing carbon at high rates and filtering water that flows from agricultural land into lake systems. They provide habitat for dozens of endemic fish species, numerous amphibians, water-dependent mammals, and an extraordinary diversity of birds. The shoebill is, in this context, both a symbol of the health of these systems and a beneficiary of their productivity. Where papyrus swamps are intact, shoebills persist. Where swamps are drained, burned, or converted to agriculture, shoebills disappear, and they take with them their unique ecological function and the irreplaceable weight of their evolutionary history. Part 6. Human Connection and Conservation. The shoebill has known human beings for a very long time, though the relationship has been complicated by geography, misunderstanding, and in recent decades the accelerating pace of habitat destruction. In Sudan, where the bird is known historically as Abu Markub, it occupied a specific cultural niche. Arab traders who encountered it were struck by its strange dignity and by the observation, noted by multiple early travellers, that the shoebill would allow humans to approach within a relatively short distance without fleeing. This tolerance, unusual for a large wild bird, seems rooted in the shoebill's evolutionary history in a landscape where it was not regularly hunted and where human disturbance was not a consistent threat. The result is a bird that does not read humans as predators in the automatic, instinctive way that most wild animals do, a trait that has made it both endearing to tourists and vulnerable to poachers. In some parts of Uganda and Ethiopia, shoebills have been regarded with a mixture of respect and mild superstition. They are associated in certain local traditions with rain, with swamp spirits, and with good fishing. Perhaps because their presence genuinely does indicate productive fishing waters. Whether these associations translated into active protection is difficult to generalize, but there are documented cases of communities that refuse to harm shoebills and that describe disturbing a shoebill's nest as bad luck. More recently, the shoebill has become an important ecotourism attraction in Uganda in particular. The Mabamba Swamp on the northern shore of Lake Victoria, the Murchison Falls area, and the Bangweulu wetlands in Zambia all receive visitors specifically seeking encounters with shoebills. The economic value of these encounters has been well documented, and has in some places created tangible local incentives for protecting the swamps and the birds within them. A live shoebill in a productive swamp reliably attracting paying visitors over many years is worth vastly more economically than a dead one or an empty swamp converted to rice paddies. Yet the conservation picture for the shoebill is not reassuring. The species is classified as vulnerable on the IUCN Red List, and current population estimates range from 5,000 to 8,000 individuals, a number that sounds substantial until you consider how large the range is, how specialized the habitat requirements are, and how slowly shoebills reproduce. The primary threats are well understood if not yet well controlled. Habitat loss is the most significant. The papyrus swamps of East and Central Africa are under relentless pressure. Agricultural expansion, particularly for rice, sugarcane and smallholder farming, converts wetlands to dry land at rates that have accelerated with population growth. Drainage schemes, road construction, and the damming of rivers for hydroelectric power all reduce or fragment the habitat that shoebills require. The papyrus swamp is not generally regarded by the people who live adjacent to it as a resource to be preserved. It is regarded as land that could be made more productive, an attitude that is difficult to argue against in regions where food security is a daily concern. Charcoal production and papyrus harvesting for crafts and construction represent additional pressures that are smaller in scale but widespread across the range. They do not eliminate wetland habitat outright, but they degrade it, reducing the density and diversity of vegetation, disturbing nesting birds, and opening up areas to increased human access. Human disturbance of nesting sites is a particular concern. Shoebills nest in remote areas precisely to avoid disturbance, but the increasing penetration of human activity into formerly inaccessible swamps, through fishing, honey collecting, and now, ironically, ecotourism, means that even the most remote nests are no longer guaranteed quiet. Nest abandonment as a result of disturbance during the incubation period can cost a breeding pair their entire season's reproductive effort. Hunting and egg collection, while illegal under national laws in most range states, continue in some areas. The shoebill's large size and its relative fearlessness around humans make it an easy target. in regions experiencing conflict, and the Shoebill's range includes some of the most conflict-affected areas on the African continent, including parts of South Sudan and the Democratic Republic of Congo. Conservation enforcement is simply not a priority. Fishing practices add a further layer of pressure. Entanglement in fishing nets is a documented cause of shoebill mortality, as is the reduction of fish stocks through overfishing, and the use of destructive fishing techniques including poisoning and electrofishing. A shoebill that cannot catch enough fish to sustain itself does not starve dramatically. It simply stops breeding, or abandons its territory, or disperses into marginal habitat. The population impact is diffuse and slow, which makes it all the more insidious. Conservation efforts for the shoebill are ongoing but underfunded and geographically uneven. Uganda has the most established shoebill conservation infrastructure, with several protected wetland areas, active monitoring programs, and community-based conservation schemes that pay local fishermen as shoebill guides and give them a financial stake in the bird's survival. The Wildlife Conservation Society and BirdLife International have both been active in shoebill research and advocacy. Camera trapping, satellite tagging, and nest monitoring have improved our understanding of population dynamics, dispersal patterns, and breeding success over the past decade. What is needed but remains elusive is the integration of shoebill conservation into the broader economic planning of range states. The recognition that the intact swamps that shoebills require are not unused land but functioning ecological infrastructure that provides water filtration, flood control, fish nursery habitat, and carbon storage. Making that argument compellingly, in regions where immediate human needs are pressing and where the long-term value of wetland services is not easily monetized, remains one of the central challenges facing conservationists across Africa. Part 7. Final Thoughts. Let us return, one final time, to the swamp. The shoebill that struck at dawn has relocated. It is standing now in a slightly deeper channel, partially concealed by a stand of papyrus that sways gently in the late afternoon wind. The light is different at this hour, golden, horizontal, finding its way through the vegetation in slanted columns that illuminate the mist rising off the water. In this light, the bird's grey plumage takes on a subtly warmer cast, and the pale eyes catch the sun for a moment and glow. It is motionless. It has been motionless, on and off for most of the day, interrupted only by 2 more hunting strikes and the long, deliberate walk between this channel and the previous one. It has eaten. It is not in a hurry. There are no predators in this swamp that it fears. There is no competitor it needs to impress. It is exactly what it is, in exactly the place it has always been. Today we've traced the full arc of that existence. We began in the Eocene, in the warm, wet Africa of 35 million years ago, where the ancestors of this bird were already working out the equations of beak and water and patience that would eventually produce Balaniceps rex. We watched the evolutionary logic of its body assemble itself across geological time, the forward-facing eyes, the massive beak, the metabolic discipline, the long toes, each feature a chapter in a very old story about survival in a very specific place. We watched the egg laid in a nest deep in the papyrus, tended through the equatorial heat by parents who carry water in their beaks to keep their unborn offspring alive. We witnessed the brutal efficiency of the sibling dynamic. One chick's dominance buying the survival of the lineage at another chick's expense. We followed the juvenile through its long, exposed adolescence, the early flight attempts, the failed hunts, the slow, solitary education in the art of reading water. We arrived at the adult in its full authority, the territorial bird, the seasonal mate, the patient hunter, living out a life measured in decades and governed by a routine so consistent it might look from the outside like serenity. We examine the ecosystem that depends on this bird and that the bird depends on in return, the swamp as a living system, the lungfish as an ancient counterpart, the community of water and vegetation and animal life that has co-evolved over timescales we struggle to comprehend. And we confronted the uncertainty that surrounds its future, a species of 5,000 to 8,000 individuals distributed across some of the world's most biodiverse and most pressured wetlands, reproducing slowly, requiring intact habitat, and facing the combined weight of agricultural expansion, climate variability, and the perennial difficulty of making the long-term case for preservation in environments where short-term need is urgent and loud. The shoebill is not a dinosaur, it is not a museum piece, it is a living, functional, irreplaceable part of the African wetland world. A predator at the end of a lineage that has survived ice ages, tectonic shifts, the appearance and extinction of countless other species, and the slow transformation of an entire continent's hydrology. Its continued existence is not guaranteed, but it is not yet lost. There is something instructive, perhaps, in the way the shoebill itself approaches uncertainty. It does not panic. It does not react to every disturbance with flight or alarm. It stands still. It reads the water. It waits for the right moment, and then it moves with everything it has. We could do worse than to take notes. The shoebill bows its enormous head once, that characteristic dip that local people read as a greeting, that scientists describe as a threat display, and that feels, in the failing light of an African evening, like something more difficult to categorize, an acknowledgement perhaps of being seen. Then it is still again. The swamp breathes around it, and the water, which has been here long before either of them and will be here long after, moves on. If you enjoyed this episode of Animal Uncovered, following the podcast is the best way to support the show. And if there's an animal you want us to uncover next, leave a review or comment and let us know. Until next time.